All right, so welcome to today's ACUR at ANU group presentation session. Thank you for joining us. Before we begin, I would like to acknowledge and celebrate the first Australians on whose traditional lands we meet and pay our respects to the elders past and present. My name is Aidan Delaney and I'll be chairing today's session. Our first presenters for today are Daniel O'Connor, Patrick Capaldo and Jason Huynh. So I will hand over to them and please start when you're ready.
Thanks, Aidan. Good afternoon. My name is Jason. As a team, Patrick, Daniel and I have been working together to extend the capabilities of commercially available sensors by integrating them with an unmanned aerial vehicle. This is our Mechanical Engineering Honours project at the University of Adelaide, and it is sponsored by Defence Science Technology Group. One potential application of our project involves monitoring bushfires by communicating with and adaptively positioning small sensors. It is known that variables such as the moisture content, wind speed and direction, and the ambient temperature are all key to monitoring the spread of fire. Each of these bushfire spread indicators can be measured with relatively cheap commercial off-the-shelf items such as a small camera, a digital thermometer, or a smoke sensor. However, the underlying issue is that because of their simplicity, these small and cheap devices are generally immobile and are consequently susceptible to losing their effectiveness if the local environment evolves. Our project aims to extend the reconnaissance capabilities of these sensors by transporting them with a drone. This recently recorded flight trial demonstrates our project simulating its expected operating procedure in the field. To achieve our project aim, we defined 3 objectives. The first is to develop a small, low-cost sensor payload. Another objective is to assemble the UAV to transport a sensor. And the third objective is to establish real-time communications between the sensor, vehicle, and a central analysis station. In this presentation, we'll delve into the engineering detail involved in our research project. Specifically, we'll elaborate on the techniques required to complete each phase presented in this flight trial. We'll begin with the UAV flight, then the payload collection phase, and lastly, the design and communications of the payload sensor module. Patrick will now discuss the flight phase engineering.
So in preparation for the trial flight shown previously, full software simulations, as shown here, were utilised to become familiar with monitoring the UAV status. So for example, warning messages or telemetry. And this was achieved using a ground control station, which is shown on the left here. And this looks the same whether it's communicating to a virtual or a real UAV. So therefore, one can practice monitoring the UAV in a low-risk virtual environment before doing so in a high-risk real environment. And this ultimately improves the safety of our real test flights. And so as the assembly of the UAV progressed and ultimately reached completion, the performance of individual hardware components was validated by substituting them for their software counterparts and then repeating these simulations. So this improves the confidence in the reliability of each physical component before they are integrated into the UAV system. And so, for example, in this video, the autopilot's positioning is being validated by moving the module around and checking that the telemetry responds accordingly. So a fundamental finding which forms the basis of the design of a UAV payload system is the configuration of a towed UAV system. And so literature suggests that the greatest stability of the vehicle is achieved when the payload tether is attached as close to the vehicle's center of gravity as possible. And additionally, deliberate selection of an autopilot that's capable of correcting for the disturbances of a payload was required. A flexible tether material was chosen as it does not judder the airframe on landing, is less dependent on landing accuracy, and introduces less airframe twisting compared to a rigid connection. And this lesser airframe twisting will increase flight endurance and provide faster control response. The trade-off here being that a flexible tether has a higher chance of the payload colliding with the propellers or bump in the airframe during flight. However, sensible flight, confidence in the autopilot's correction for bumping, and the desire for a lesser dependence on a high landing accuracy encourage the selection of the flexible material over the rigid. And so now moving on to the collection phase. To increase the autonomy of our system, we will be utilizing infrared guided landing to land above and collect the sensor payload. So the approach uses a beacon positioned on the payload, and you can see the blue modules in the video there, and an infrared homing camera on board the UAV, which I'm holding in my hand here. And in this video, we can see what the camera sees. So the landing accuracy is approximately 10 centimeters. However, this is unlikely to be sufficient for payload collection purposes. And this drives the need to develop methods to compensate for this inaccuracy. And so Jason will now discuss a method for this compensation and the gripping mechanism.
One such method to compensate for the landing inaccuracy is to utilize a funnel-shaped guide above the payload. As you can see in this video, this feature allows for misaligned landings to still have complete gripper contact with the payload. Furthermore, the funnel design also accommodates the minor swaying motion experienced by the UAV due to the more turbulent air when hovering close to the ground. In order to collect the payload, an electro-permanent magnet is utilised. This was selected as it only requires power when magnetising and demagnetizing. It has no moving parts, and it can be remotely operated away from the drone.
Moving on to the payload module, after nominating a sensor for prototyping, the communication methods and mechanical casing are designed. Initial iterations of the sensor were prototyped with two small Bluetooth-enabled Arduino computers with numerous electronic components such as resistors, diodes, and transistors, powered by a USB cord. To demonstrate a proof of concept in communicating information through Bluetooth, a button was utilized to send binary on and off data. As shown in this video, when the button is pressed on one device, a light appears on the other. This confirms the capability for one device to reliably communicate data to the other in real time. The next iteration demonstrates the capability for text communication. Using the Arduino serial monitor, which allows for user input, it can be seen that the two devices can send and receive text messages between one another. The next iteration of the payload is, as you may have guessed, the sensors themselves. By introducing 9-volt batteries as a power supply, wireless communication can be achieved, eliminating the requirement for a USB cord. Similarly, replacing the button, as seen in the previous video, inexpensive, off-the-shelf sensors may be integrated with ease into the wireless Bluetooth-enabled payload device. As shown in this video, combining the findings from each of the previous iterations, a smoke detector sensor is seamlessly implemented into the payload device, to which when smoke is detected, a message is communicated in real time. Through integration with the Bluetooth capability of the UAV's onboard Raspberry Pi, this data may be reliably communicated to the UAV during flight. Currently, 3 distinct payloads have been developed: a smoke detector, temperature sensor, and sound sensor. These devices have been refined into printed circuit boards, as shown on the right here, in order to increase durability and robustness. These sensors have each been tested both as independently operable sensors and as communicable sensors, thus they can be used both with or without the UAV present. In order to allow the payload to be safely and securely transported by the UAV, a payload casing has been designed and manufactured. This casing is 3D printed in order to find a balance between cost, mass, and durability. It features a metallic plate and cone on top for the gripper, as Jason mentioned earlier. Moreover, the selected casing features infrared beacons, as Patrick discussed, such that the UAV may be able to accurately detect and collect the payload. As shown here, it is evident that after the UAV detects the infrared beacons from a distance, it is able to gradually approach the payload casing. As soon as the magnetic gripper is in close proximity to the casing, it is guided towards the plate via the cone. Then, once the gripper reaches the plate, it is activated and can ultimately transport the payload. The progress made thus far unequivocally demonstrates the capability for a low-cost solution to problems like bushfire monitoring, but also countless other sensor-enabled problems such as medical or agricultural applications. It is clear that modular sensors integrated with a communicable UAV have strong potential to accurately and adequately monitor situations, removing involvement or danger from human operators who might otherwise be directly monitoring the situation. We would like to give our sincere thanks to DSTG and the University of Adelaide for their ongoing support throughout the span of this project. What we have achieved thus far would not have been possible without their help. And of course, thank you very much to everyone here today for spending your time to listen to our presentation. We would greatly appreciate any comments or questions you have on our work so far or going forward.
Wonderful, thank you for that presentation. So we now have 5 minutes for Q&A, and I'll begin by inviting the judges if you have any questions for the group.
I can go on with the first question. And really interesting presentation, thank you so much. I've got a question about the infrared beacons and using them for detection, basically, of where the sensors are. And so my question is, how close do you need to be to the target for the infrared beacon to work, and what's the range?
I mean, according to the manufacturer's specifications, the infrared beacons coupled with the infrared camera that we're using are rated for a detection range up to 20 meters.
Okay.
When we were calibrating the system, we tested it at 15 meters, which we've said to be more or less appropriate for the scope of our project. Keep in mind that we're still in the prototyping stage.
So I guess my next question is, what were your biggest challenges, and what would you do differently if you were to take this to scale?
I mean, thanks for the question. I think we would all agree one of the biggest challenges with this project was assembling the drone in the first place. I guess something we might improve on if we did it again was maybe slightly more in-depth research into how the drone's assembled in the first place, because we spoke to experts in the field and they did say that, you know, it's fairly straightforward. It's just like basic electronic skills. But again, we are mechanical engineers and aerospace engineers, so we have some very basic electronic skills, but we weren't quite expecting to learn as much electronics as we did. The skills like soldering and voltage checking, current checking, and putting it together was a massive challenge. But we had some hurdles, but we got there in the end, which is good. Yeah.
I guess that's a perfect segue into my next question, which is, what sort of redundancy were you thinking, or are you thinking to implement in the system for different failures of different components in the future?
We've got quite a few redundancy plans in place, spanning the entire scope of the project. So we've got redundancies in terms of mechanical systems. So for example, the selection of a hexacopter over a quadcopter, which is typically a more popular drone option, was decided because in a hexacopter, if one or two propellers fail, the system can still remain airborne, and although a degree of controllability is lost, it's still more or less safe to fly and safe to return back to home. We've also got redundancy in terms of our software systems. So with our sensor payload, it's communicating via Bluetooth to an onboard computer, a Raspberry Pi on the drone. But a redundancy plan in place is that in the case of the computer on board the drone failing, the plan is to have the payload communicate directly back to the ground control station, that central analysis station, removing, I guess, the UAV as an intermediary, but still allowing us to receive the critical real-time sensor data.
If I can just build on that, Jason, so the initial plan is to have the sensor payload to communicate to the UAV and the UAV to communicate to the ground station. If the communication between the UAV and the ground station fails, we're also recording a log of all sense data on the UAV. So throughout the entire flight, the UAV is consistently recording whatever the sensor is sensing, so that which can be retrieved after the flight is finished.
Perfect, thank you.
Okay, are there any further questions? very quickly, if the audience, if anyone wants to raise their hand, I can unmute you, or we have the chat function for questions.
If I can add one last comment, there is a research project happening at ANU about detection of bushfire using drones, so you might want to get in contact with this group. And it's in collaboration with the environmental science and the robotics schools at ANU.
Yeah, that sounds interesting. We'll look it up. Thanks, Mina.
All right, excellent. Thank you, everyone. That brings us to time. So we'll now move on to our second presentation for today's session. So I'd like to invite Darsiha, Balakirishnan and Nibras Jasim. Please start when you're ready.
Good afternoon, everyone. My name is Nibras Jasim from Western Sydney University. Today, I'll be presenting with my colleague, Darcy, the research titled The Effects of Tai Chi on Early Stage Dementia, a Scoping Review. So what is dementia? Dementia is a syndrome associated with over 100 different diseases where cognitive impairment interferes with physical and social functioning. It is predicted that dementia will affect as many as 152 million people by 2050 worldwide, compared to 15 million in 2018. The symptomatic prodromal phase of dementia, also known as mild cognitive impairment, MCI, is characterized by a decline in cognitive function and intact instrumental activities of daily living. Also, it is considered as a transitional phase between neurotypical cognitive aging and dementia. There are other health problems associated with mild cognitive impairment, such as increased falls risk, osteoarthritis and pain, poor balance, depression, and loneliness. The negative effects of MCI increase with age. Approximately 35% of Australians aged 70 and older were found to have MCI, among which 50% will go on to develop dementia within a year. So now, why it is important to do the study? Currently, the benefits of pharmacological interventions are limited to symptomatic relief for people with dementia. Therefore, non-pharmacological interventions have gained much attention for cognitive rehabilitation as a complementary therapy. Tai Chi is considered as a multi-component mind-body exercise because it incorporates physical, cognitive, social, and meditative components in the same intervention. We had two research questions. The first, what are the neurocognitive, physical, and psychological outcomes assessed in systematic reviews on Tai Chi for people with cognitive decline, including MCI and early stage dementia? The second question, does Tai Chi improve neurocognitive, physical, and psychological outcomes in this population? Now, Darcy will talk about the method section.
So the synthesis process of the scoping review was guided by the Joanna Briggs Institute Manual for Evidence Synthesis, as well as the Grade Handbook. A number of predefined criteria had to be met by the studies that for inclusion in this review. We included adults aged 50 years and older with a risk of dementia, or they were diagnosed with early stage dementia or mild cognitive impairment. All styles and forms of Tai Chi and their training regimens were included as for the interventions, as well as all featured controls. The most recent comprehensive and high quality systematic reviews with meta-analysis of randomized control trials and or non-randomized studies for interventions were selected. Additionally, any RCTs that were not included in these systematic reviews, they explored unique outcomes, as well as meeting our criteria were also selected. In order to find our eligible articles, we searched major English and Chinese databases as listed right here from their inception till December 2020. When we conducted the searches, we used the following search terms in the English databases as shown in the table right here. In terms of the methodological quality of the included systematic reviews and RCTs, we assessed them using the critical appraisal tools AMSTAR2 and Cochrane Risk of Bias respectively. Further quality assessment was done on the systematic reviews using GRADE to evaluate their certainty and their reported measures of effect, which was characterized as high, moderate, low, and critically low qualities. Now I'll pass it on to Nibras to talk about our results.
569 studies were identified, among which 14 studies were included, including 8 systematic reviews with meta-analyses and 6 randomized controlled trials. The diagnosis of the participants included early-stage dementia and specifically mild cognitive impairment. Participants were aged between 55 and 85 years old. Tai Chi was included as part of an array of mind-body interventions or exclusively as an intervention for the experimental group. The control interventions included stretching and relaxation exercise, no intervention, health education, handicraft, usual lifestyle, or memory training. Now we go to the effects of Tai Chi and the evidence from the meta-analysis. We identified neurocognitive and psychological outcomes. The neurocognitive included global cognition that was found in 4 systematic reviews and assessed by 6 scales. 4 of those 6 scales were significantly better than the control group. 2 of them weren't significant, and their grade certainty ranged from moderate to very low. The attention and executive function found in 3 systematic reviews assessed by 5 measurements. 1 of them was significant and 4 weren't significant, and the grade certainty ranged from moderate to low. The memory found in 3 systematic reviews and assessed by 3 measurements. 2 of those were significantly better than the control group, and 1 of them wasn't significant. And its certainty, the 3 of them, their certainty ranged from low to very low. Language and perceptual motor function was found in 1 systematic review and was measured by 2 scales. 1 of them was significant, 1 wasn't significant, and both of them were of moderate certainty. The psychological outcomes, we found depressive symptoms that was measured in 1 systematic review and measured by 1 scale. And it wasn't significantly better than the control group, and it was of moderate certainty. Now we go to the effects of Tai Chi and the evidence from the RCTs. We found the neurocognitive outcomes, psychological outcomes, and physical outcomes. So the neurocognitive outcomes included global cognitive function and were found in 3 RCTs measured by 5 different scales. 1 of them was significantly better than the control group, and 4 of them weren't. The memory was found in 1 RCT measured by 1 scale, and it was significantly better than the control group. For the physical outcomes, the pain was found in 2 RCTs measured by 3 different scales. 1 of them was significantly better than the control group, and 2 weren't. The balance was found in 4 RCTs and measured by 8 different scales. 6 of them were significantly better than the control group, and 2 of them weren't significant. The psychological outcomes were measured by 1 RCT and 1 scale, and it was significantly better than the control group. Now we return to Darcy to talk about the discussion section.
So to the best of our knowledge, this scoping review is the first to comprehensively evaluate systematic reviews, meta-analysis, and RCTs on the effects of Tai Chi on various outcomes in individuals with early stage dementia. When we come to the findings, overall, this review found that Tai Chi had a mixed effect on neurocognitive, physical, and psychological outcomes amongst people with early stage dementia. And we found differences between groups were inconsistent. So these discrepancies in results may come down to variations in control groups. For example, 1 meta-analysis had singing as a control group and another had playing cards. There was also variations in the target populations that also has to be taken into account. So these varied from only MCI to some studies having a combination of MCI, dementia, and cognitive impairment. Another potential reason for this inconsistency could come down to the varying nature of the tools or measurements used to evaluate the outcomes. For example, for global cognition, numerous scales were used across the studies. So we found MMSE, ADAS-COG, and MOCA. So all these variations could have contributed to the mixed effects that we saw in the results. So the big question is, so where to hear from now? So to address the gap in the current literature that we did find, we recommend that future studies need to investigate the effect of Tai Chi exclusively on people with early stage dementia and MCI, because we found not many studies targeted that population. Additionally, since the included studies in our review did have a low quality, we suggest that future researchers analyze high quality RCTs to increase the certainty of their conclusion. While we don't have strong evidence for the benefits of Tai Chi as of yet, it is still considered a safe and healthy form of exercise that all participants can practice. Ultimately, we hope that our work paves the way for Tai Chi in one day to be recommended by health professionals as a complementary treatment for early stage dementia. Thank you everyone for listening. Hope you enjoyed that.
Thank you very much for that presentation. So we'll now move to 5 minutes for Q&A. And again, I'll begin by inviting the judges if you have questions for the presenters.
I've got a few questions, but let me start first by the data that you collected. And how do you think you could quantify the data, especially for a certain area where quantifying results of use of Tai Chi to help reduce or even prevent something like dementia is pretty subjective?
Now we found many systematic reviews in RCTs that have implemented Tai Chi as an intervention to delay the progress of dementia, and they actually found it's statistically significant that Tai Chi can reduce the progress of dementia, delay the progress of dementia. However, it's still new to the literature, so there's still a lot more to be done. With the systematic reviews that we identified, each RCT within those systematic reviews, they implemented different duration for practice and different times per week. Some of them only 30 minutes twice a week, some of them 90 minutes 4 times a week. So there's a huge difference. So at this stage, we cannot recommend Tai Chi in a very concrete way. Like we can't say just a certain duration for a certain amount of time or per week. Lots of studies need to be done so we can be very clear on the amount of Tai Chi that we need to practice, the amount of time, and the frequency of the practice. So there's a lot still need to be done.
Thank you. My second question is about, have you considered different cultural perceptions, different perception of exercises and activities like Tai Chi, and how would you go around this and or maybe use it to your favor if results one day prove that it is effective in preventing or in delaying the effects of dementia?
I think like we were talking at the end that maybe health professionals can recommend it, not prescribing it, but just the recommendations for patients that have early stage dementia or mild cognitive impairment. And then health professionals can tell them of all the benefits of all the research that there is, and maybe they can let the patient know why that's better than the other treatments currently there. And because we're trying to use it as a complementary intervention, so it's with pharmacological intervention, it's a combination with pharmacological intervention. So if we've got solid evidence to prove Tai Chi as a complementary intervention with pharmacological, if there's strong evidence for that, I think patients would look into that as well. So I think, yeah, it comes down to health professionals shining a light on the benefits of Tai Chi to their patients.
I just want to add to this, we included the major Chinese and major English databases, and from what we found actually studies on Tai Chi have been made in different countries, like in Turkey, France, of course, China, US. So we found it around the globe. So I guess it's a bit known, it's well known in different countries around the world. But as Darcy said, if in the future we will recommend it, then it's going to be, you know, well promoted.
Thank you.
Great. If that's all the questions from the judges, we do have an audience member, so I'll just allow you to talk.
Hi, thanks for the great presentation. I had a couple questions. So were any of the patients in any of the papers diagnosed pathologically, or was it just purely a cognitive assessment?
They use the cognitive assessments like MMSE, ADAS-COG. So prior to accepting people into the RCTs or even the non-randomized control trials, the researchers assessed their participants, and according to particular numbers of the scales, they accepted their participants. And in our study, we were very clear on our criteria. We included people with mild cognitive impairment and early stage dementia. And to answer your question, yes, the researchers assessed the cognitive functioning of their participants before accepting them to their study.
Yeah.
Okay, that does bring us to time for Q&A. So unfortunately, I'll have to end it there and move on to the next presentation. But thank you again for that presentation. So we'll now move to our final presentation for today's session. And so I invite Shannon, Campbell and Zoe Chandler. Please start when you're ready.
Okay, cool. All right. Well, thank you for coming. Welcome to our presentation. So it is on expert evidence. So it's on expert evidence and their use in the court. So today we intend to go through the importance of credible expert evidence, why you should care, and to also showcase the research we have conducted. For those who've seen The Big Lebowski, I hope that you appreciate the reference or at least know the quote. All right, so our title comes from the role of the courts to find facts. A fact is something which is proved to be true and is not subject to interpretation, while an opinion is inference based on a source of information. It makes sense that evidence must therefore exist for the court to find proof of a fact. This evidence can come from various sources, including experts who assist the court with different specific information, without which evidence may be misconstrued. Often evidence is expert evidence is accepted as fact, but concerningly, almost anyone can become an expert if they possess the knowledge beyond that of the court. This makes the distinction between fact and opinion especially important. So why are we doing this? Well, Zoe and I come from very different fields. She is in the forensic discipline and I am in the legal profession. We acknowledge the issue of expert evidence is interdisciplinary and different perspectives are required to solve the problem. From our preliminary research, we discovered that although considered reliable and afforded significant weight in a legal setting, forensic science methods aren't necessarily reliable in a scientific setting. There has been ongoing scrutiny from independent reports over the last decade reporting forensic methods are seldom supported by scientific rigor and are often ridiculed with errors. They also rely heavily upon human judgment. Unfortunately, jurors and judges lack the ability to properly scrutinise scientific evidence, demonstrating part of the disconnect between concepts of credibility in science, law, and to the public. In fact, former Chief Justice French once said, "There are interesting questions about the differences between the legal and scientific method and whether they can ever properly mesh or are fated to be like ships passing through the night." So that was why we did this research, to bridge this gap by bringing transparency and awareness to the reliability and accuracy of forensic expert testimony, and to examine to what extent popular beliefs about expert credibility are reflected by scientific and legal definitions of source credibility. So enough about us, why should you care? All expert evidence requires a form of human judgment or interpretation. In forensic science, experts often visually compare samples to evaluate the likelihood of a match. While research such as the work from Searson and Tangen has supported the accuracy of forensic experts, the human element is still present and errors may occur. Part of the problem is tunnel vision by experts and legal professionals, whether wittingly or unwittingly. It is not unusual for experts to become indoctrinated in their area and believe in their practice and procedure. With direct and subtle influences, bias can impact an examiner's finding and judgment. Bias may arise from various sources as outlined upon the screen. For example, studies from DRAW have shown forensic judgment can be influenced by knowing the determination of other examiners or contextual information, and can also be influenced by the position of the party who hired them. Forensic evidence is only as good as the source materials, and if errors occur at any point in the process, they may make their way into trials, which has obvious implications on justice.
We can all think of characteristics that we consider to be diagnostic of an expert. However, what makes a credible expert is encoded into a set of norms that are different in each field. We are more receptive to those we perceive as credible, and this is called source credibility. The table on the screen is a set of norms outlined in the literature that science and law consider to be credible. To summarize the content, legal definitions of source credibility focus on if the evidence can assist the court, such as relevance and knowledge beyond the court, while scientific definitions focus on characteristics of an individual expert, such as clear logical reasoning, being consistent with others. Neither of these focus on the quality of the evidence, such as methods or limitations. As you can see, the judges and the scientists don't really share the same concept of credibility, and different metrics exist to achieve it. I didn't go so I think I went too far.
Yes, I apologise. Sorry. Let me outline what can go wrong with flawed forensic evidence. This is the case of Eastman and the Queen. In 1989, the Assistant Commissioner of the Federal Police was shot dead. Prosecution had extensive evidence against Eastman and convicted him of murder. For example, expert evidence produced alleged the gunshot residue in Eastman's car and the scene of the crime matched and was from a particular brand of ammunition. When an inquiry was conducted, it was found the expert lacked relevant tertiary qualifications, independence, and had bias for their methods and findings, among other problems. Guilt was determined on extremely flawed expert evidence, leading to a miscarriage of justice. Our research aims to combat this problem.
So now let's outline our research. Our first step was to search the literature for characteristics of accuracy of experts in law and then in science. The second step was a pilot study published on an online recruitment platform where 142 participants were recruited and given a case scenario, putting them in the position of a jury member in a criminal trial. Participants were asked to outline what characteristics they believe makes a credible expert in an open-ended question, which was the qualitative data, and then they were also requested to rate 36 predetermined characteristics on a scale of perceived credibility, which was the qualitative data. These 36 characteristics are what we believe encompasses credibility based on the literature. Step 3 was to analyze the survey results using first an exploratory factor analysis, reducing the initial 36 characteristics to 4 broad factors, and then the qualitative statements were rated against these 4 factors. We'll show these results in the coming slides. Other cross-validation was also done, which showed internal consistency and reliability. Step 4 was that we used these results to collate a credibility checklist. We'll have more on that later. So for the quantitative data, we reduced the 36 variables to the smallest number of factors based on variance by the exploratory factor analysis. This resulted in the 4 factors of reliable, rigorous, confident, and conservative. The mean change in credibility of these factors is seen on the slide, with reliable being the most influential factor on positive change of credibility. The qualitative statements were rated for similarity on the 4 factors by independent examiners. We found that 73.8% of the descriptions were highly similar to theoretical descriptions of reliability, which matches up quite nicely with the findings of the quantitative data. We found reliability is holistic and encapsulates individual characteristics, transparency, the methods used, and the field of expertise. Reliability was the most influential factor on an expert credibility and explained most of the variation in the results. So this is what people believe makes a credible expert. We essentially found that experts are perceived as more credible when they openly disclose their methods, uncertainty of information, limitations, possible sources of bias, and the scientific evidence underpinning their claims. They are also thought to be more credible with seniority and relevant formal qualifications. Certainly, these outcomes seem obvious. However, in the justice system, there is tension between the efficiency and pursuit of truth. The disparity between understanding creates concern that judges and juries will over or undervalue expert opinion if the experts are fully transparent. But our results demonstrate that this is not the case. As a result of our findings, we collated a checklist of 14 factors to assess credibility of an expert. Many of the attributes overlap with prior research, but we expanded to provide a greater focus on transparency in particular. Our results indicate that the reliability of an expert is not confined to individual characteristics or variables within their control, but encapsulates the broader scientific area as a whole. When combined with the concerns raised in independent reports, this is appropriate to modify the past checklist. Unlike previous research, this checklist comprises results from quantitative and qualitative data and considers actual perceptions of credibility rather than only theoretical perceptions. This allows a holistic view of the sources of credibility and is able to be used as a uniform standard of assessment.
So we've spent some time looking at issues with forensic science, but when properly evaluated, it can be useful for the court. In Karga and the Queen, Mr. Karga was charged with breaking into the victim's house and strangling her to death. Samples were taken from the deceased and subject to a DNA analysis. What was interesting about this case was the in-depth analysis of the DNA evidence and expertise by the judge. For example, the method taken by the forensic team was outlined, evaluated and compared with published articles from all over the world. Bias was considered, DNA evidence itself was evaluated, and other methods, limitations and reproducibility were discussed. Transparency, accuracy and reliability were focal points of the decision, but this methodology is seldom followed with rigour and approaches different in each jurisdiction. This presents a need for an evaluative tool such as our checklist. Overall, our research is a step towards bridging the communication gap between science and law and addresses deficiencies in current research and practice. We have created general consensus to understand credibility, allowing everyone involved in the justice system to be on the same page. The checklist we propose encompasses scientific, legal and lay definitions of source credibility to enable a comprehensive evaluation of the expert, the evidence and the scientific background being relied upon in the court. Having all this information available enables full transparency before the court and reduces the risk of an inquest years later after justice has been miscarried. After all, it is a presumption of innocence until guilt is proven beyond all reasonable doubt. Reasonable doubt may still exist if an in-depth evaluation of guilt is presumed due to lack of transparency or questions around expert credibility.
Okay, that does bring us to time, unfortunately, so we'll have to...
I apologise. Yeah, it was about to say, well, this concludes our presentation anyway, so...
Thank you for that. So we'll now...
Our computer was a bit slow, so I kept hitting the button.
No worries. Thank you for the presentation. So we'll now again move to 5 minutes of Q&A and begin. I think one of our judges has some questions for you.
Hi, yeah, my name's Elaine.
Oh.
And my question is in relation to, Zoe, your research is, your background is in fingerprint. Is that, did I understand that right?
Not really, but
Oh, okay. Anyway, so my question related to, although the focus of this research was on trying to make expert evidence more transparent and accessible, presumably for juries and for members of the justice system. I was wondering about, the other side, the other way of appreciating how the justice system is, like you said at the end of your presentation, is to protect the, protect those who are being charged with an offence. So, and I was wondering why. Is DNA evidence and the processes, the legal processes are for collecting DNA evidence or even any other forms of evidence for a trial. I was wondering if that had been considered.
So
why it hadn't been considered.
I'm sorry, I don't quite understand what you mean.
Okay, so there are legal requirements when collecting evidence for a trial. Yeah. And I was wondering why those legal requirements, whether they were like the purpose of those legal requirements, if they hindered at all the ability to provide expertise.
Okay, I apologise. I can answer that. Yep. Because I have a legal background. Yes. I agree. We do have, standards, but they're quite limited. And the thing is, judges, legal professionals don't understand, or do they really care what actually happened when it comes to collecting evidence. if they were to do an inquiry upon the types of evidence, it would go to, I guess, a mini trial within a trial. So that's called a voir dire. And that's just a lot of time, effort, money. So it's, for more often than not, it doesn't, especially when it comes to things like forensics, they don't really bother. They just accept that it's, I guess, accurate, if that makes sense. There's even a case out there, I think I can't recall off the top of my head, but it even says that even if the evidence method is kind of faulty, you can admit the evidence anyway, because the legal standard is that it will come down to the weight of the evidence. So anything that is relevant is admissible, but then it comes down to the weight that will be given. So that includes even faulty evidence, believe it or not, which is quite concerning, actually.
Okay, thanks.
Sorry, any further questions from the judges? If not, I believe we have a question here.
Hi there. Thanks for the presentation. I was just wondering how you ensured that your online survey had a random sample of participants, or that there wasn't any unexpected biases from the data that you were getting from that?
Yep, I can answer that. So the platform we used was Prolific Academic, which enables you to sort of pick what you want out of your recruited participants. So we picked for a random distribution of different demographics. So that then recruits people from around Australia. What's that? Yeah, it was all over the world. Yeah. And make sure it's evenly distributed. If it makes you feel any better as well, we actually do have the I guess statistics about it, so schematics or whatever. So it was, I think the mean age was about 28-ish, but there was still a wide range of people from different age groups, and also it was roughly even between male and female. There was one non-binary though, so that's probably not overly reliable in the sense of, you know, I guess what they think. But yeah, and it was also quite scattered around different study backgrounds. There was not many from law and forensic sciences, which is great. There was a lot of engineering, humanities, non-forensic sciences, and other kinds of study areas. And there was also a range of people from different education. So there was.
Okay, that does bring us to time, unfortunately. So we'll finish the presentation there. Thanks very much for that. So that does bring us to the end of today's session. Thank you to our judges, Mina Hanane and Aileen Walsh, and congratulations to our student presenters. Thank you for those wonderful presentations. This recording will be made available online following the conference, and we hope to see you at other conference sessions this week. Thank you.
Thank you for having us.
Thank you all for the really nice presentations.
Thank you.
Right.